and another one, and another one bites the dust. One of my Queen songs, most enjoyable Queen songs. What's a nice word now? Best Queen songs. I think another one bites the dust. Anyway, so we've done two. We started with the initial part of the project. What is our project brief? And then plotting the reserves, and then doing some visualizations of each of the reserves. Then we went into a very neat function in QGIS, which is the print layout, where we work with the canvas and we did some nice pictures and images of our images that we've created in our first tutorial. Okay, so where we are at the moment is that we have the 4 reserves. Okay, remember what our brief is. We need to do a valuation, economic valuation of the 4 reserves. That's our briefing. Couple of things that we have to do to get to that point. One is to get an understanding of these 4 reserves. What are they? How do they look? How do they change over time? What is their inherent characteristics, attributes, and all of these sort of things. As I said, first point of call, as I said, we go to Google Earth Engine and see what data sets are available that can help us put this puzzle together. Okay, and then obviously, as I said, importantly, we're running Earth Engine QGIS in parallel. What we do in the one, we do in the other one, etc., etc. Always in pairs. I don't work with either one of them singularly. I always try to work with them as much as possible in pairs. I think that brings the best out of it, out of both of these two powerful programs. Okay, so as I said, what we have an idea now is daytime images, topographical images. We get an understanding of how they look, what the terrain looks like, and all of these sort of things. Then the third step, the third video that I'm going to do is basically around clusters. So what I want to do here is to look at the heterogeneity or homogeneity of the area. I know the two color image, but again, you know, it gives you an understanding, but not the detail. It gives you rough ideas, but not the detail. Topography gave us also quite a lot of information about steepness and height and roughness and all these sort of things, which should or should not start telling us, forming us a picture of each of these 4 reserves. So what I thought then is to say, okay, what is the degree of heterogeneity or homogeneity within each area? Meaning, is it like just sand? With the whole place is just sand? Or is there lots of different vegetation or lots of different land uses, land covers, etc., etc.? Something like one would assume that, that would be fairly homogeneous. That seems to be the general trend, or, changes in biosphere, changes in vegetation occurs not suddenly and rapidly and frequently. Happens fairly slowly, happens, vegetation, typical climate goes for big area, etc., etc. So my first thought is that if it's savanna, then most probably it would be savanna for the whole area. If it's forest, it would most probably be forest for the whole area. So what I wanted to look at is the degree to which these areas are homogeneous or heterogeneous. Because that becomes our sample. If it's very heterogeneous, then obviously we have to sample in a certain way. If it's very homogeneous, then we have to sample in a certain way. If it's very homogeneous, our sample size can be smaller. If it's very heterogeneous, our sample size can be much bigger, etc., etc. So it's very important to get understanding of the homogeneity or heterogeneity of our 4 reserves. So that's what I'm trying to do here is to get understanding of exactly that. So what I do is I use the cluster function within Earth Engine. Now I can do this in QGIS as well by using the SCPD doc. Going to the band processing, there's the clustering. So I can do it in there as well. No issue with that. Or I can do it in Earth Engine. Now in this case, I've decided to do it in Earth Engine. So yeah, you can do it in, as I said, in QGIS as well using the SCP doc. It would be interesting to compare these two. I haven't done that, so maybe I need to do that as well. But anyway, that's beside the point. Okay, so there's specifically 3 clusters that I'm gonna 3 clustering methods, or the other word is unsupervised classification. Okay, not supervised, because that's when you enter the classes. Here we're doing unsupervised classification, meaning the computer or the program classifies the land cover, land use, based on its own clusters that it generates. So there's 3 that we use. So if I go down, we use the k-means, the x-means, and the LVQ. So there is 3 clustering methods that we're using. Just for interest sake, let's quickly look at the SCP doc and see what here it is distance. Okay, so there is k-means. There is minimum distance, spectral angle. So there's minimum distance, spectral angle, k-means. So which is a k-means, x-means is the same. And then the spectral angle mapping, LVQ, I think that's different. So it seems like the same maximum iterations. There's a classes is 5, etc., etc. Okay, so let's go back to Earth Engine. So I'm going to do this obviously over time. So I want to do it from in 4 batches. So I'm going to start in the early 80s, 90s, 2000s, and then current. So for that, I'm going to use Landsat 5, 7, 8, and 9. I wonder why is there no Landsat 6? Very interesting, isn't it? Bad omen or something, I don't know. Anyway, so we're going to generate a Landsat 5 image, a Landsat 7 image, Landsat 8 image, and a Landsat 9 image. And for each of these images, we're going to create a unsupervised classification or clusters. Okay, so I'm not going to go through the Landsat script. I think we've been through that quite a bit, but maybe just for Landsat 5, it would be from 1985 to 2011, and we're going to create a median image. Then for Landsat 7, it's 2000 to 2022. So that should actually be 2000. I don't want the dates to overlap. So that should actually be, let's quickly just change that. That should actually be that one there. I don't want them to, come on, I don't want them to overlap. I don't want them to overlap. Okay, just another interesting. Here I do it because it's quite a lot of work and needs a lot of computing power. I'm not doing a looping function. I'm doing each reserve individually. And all I do is I just change the ROI. So I delete the low-scope dam, I add another one, and I change the, I keep the ROI, the name the same. Importantly, a regional cluster. I'll get to that now. Okay. And then I change this where the center is, and that's it. And it will run. I keep the script. I just keep on changing this here at the top. Otherwise it's just going to bomb out. Even with this, it's with just one reserve, it bombs out. So here I don't do the looping function. You can do a looping function, but it just struggles. So my advice is don't do a looping function when it's such a high intensity job. Okay, so Landsat 5, median 85 to 2000. There is the two colors, bands, median. Okay, that's normal. That's Landsat 7. Let's just do that one there. Landsat 7 is 2022. You see, I'm going to do this 22,000. I don't want them to overlap to that extent. I want to be individualized. Because otherwise it's going to be the same one. And that's going to be, let's check that. Nope. So I'm going to do, let's say 20. Let's make that 2020. Let's make it 23. 01. And then let's take this 23. 01. And let's add it in there. Up to now. Let's run it in the medium. In the meantime, let's just take out all these ones. Because if it tries to calculate it all at once, it struggles. It's a lot. So let's just first generate. Okay, so there's my Landsat images. So one medium image for Landsat 5. So that would be somewhere in the 1990s. Then the Landsat 7. So that would be 2007, thereabout. Then this one would be about 2018. That one is there because it's the middle image, and this one would be about 2024, a middle image. Okay, so and in all cases it's a medium image. So all and then I've obviously add them to the map. Okay, so that's just standard stuff we've done through that. I'm not going to go into the detail of that. Okay, so that's our Landsat image. There should be 4 images. Landsat 5, 7, 8, and 9. I said with those, and they are medium images, etc., etc. Okay, now comes the issue of our clustering. So first, what we need to do is this called regional cluster region. So it wants the regional cluster, and you'll see I've got a regional cluster here. Okay, so it doesn't just want my ROI. My region of interest, it also wants this thing which is called a regional cluster. Now, I need to create a regional cluster for each of my ROIs. Now, the regional cluster is just a square that sits around each of these ROIs. So if I'm going to do that, that is how it looks. Okay, that's my regional cluster. Okay. Now, the size and the shape, not the size of it depends totally on you. Okay, I'll just do it in a rough format. There's no science to it. I don't think so. You just do it. Okay, so how do we do that? So let's quickly delete it. I just want to copy the naming of it. Let's delete it. So I need to add a regional cluster. So I just go to the square here. You see that? Or rectangle. I click it here to make sure that it covers my whole region of interest. And I just drag it down like that, and I left click again. You'll see it sits there now. I just changed the geometry to regional cluster, and I untick it so that you don't see it. And that's it. And so you do a regional cluster for each of the ROIs. Okay. So if I go now to $1, I will delete this regional cluster and do a regional cluster for $1. So that's the only little bit of manual work that you need to do. Okay. So I hope that makes sense. So that's important. So I've got my ROI and I've got my regional cluster. Regional cluster is a square that sits over each of these reserves. Okay. So that's important. So that's important what you have to do there. Okay. Then I've got my cluster palette visualization. I said they are clusters. Okay, so let's do cluster palette 1, cluster palette 2, and that is just when we visualize our clusters. Okay, then the training sample. Make the training sample. Training, I call it training Landsat 5 image. Now, what is Landsat 5 image? That is the median image. Where's Landsat 5? There's Landsat 5 image. It's a medium image of Landsat 5 clipped to my region of interest for that date and the applied scaling factors. Okay, so you take that sample and I include the regional cluster, scale, maximum, training. Okay. Now, once I've done my training, and basically you repeat this for each and every Landsat. So you just change it to Landsat 7, Landsat 7, Landsat 8, Landsat 8, Landsat 9, Landsat 9. But the basic script stays exactly the same. Okay, so now we're going to generate, we're going to use our algorithm. Okay, we're going to use our algorithm to create the clusters. Okay, so first we're going to train, so ee.cluster, and that's just the algorithm. 5, so K means we're using 5 clusters, and we're going to use our training that we've just done. Okay, and that becomes our cluster. The X means 4 and 5. That's just the 4 or 5, minimum 4, maximum 5. So here we want 5. Here it's either 4 or 5, and with the LVQ it is 5. So here we initiate a cluster and train it. Then in this particular cluster, the input using the trained cluster. So here we're actually doing, here we're doing the training, here we're doing the clustering itself, and here we're actually doing the display. So there we go, Landsat 5 cluster, and there we go. And so here we do the clustering and we're displaying it. And then we're doing the same for Landsat 7. We're doing the same for Landsat 8, and we're doing the same for Landsat 9. Now for Landsat 9, we have between 2 and 6. So here we have 6. Not sure why we have 6 here. Here we got 5 and 4 and 5, 5 and 4 and 5. Why do we have 6 and 6? I don't know. And obviously we export each of those ones to our carbon folder. I don't know why I have 6 and 2 and 6 and 6. I'm not sure. Anyway, so there is a video tutorial specific on unsupervised classification. Then we go into all of these details. I don't want to go into that now. If I go down it, it's really fairly in the beginning. It was fairly in the beginning. Let me just quickly see where. I don't know why the internet is so bloody slow today. It's very frustrating. Come on. That's the snow one. That was before that. Where did we do the? It was even before that. Here we go. Unsupervised or cluster classification. There we sit. Tutorial 34. Okay, so it sits in all in. There's another one in 33. Performing unsupervised cluster classification. There's another one. Performing unsupervised classification. So there they sit. Okay, so go have a look at those video tutorials. All the details are there. Okay. So bottom line is, I'm using this to get an understanding, as I said, about the homogeneity or the heterogeneity of my region. If I just like it a little bit bigger, if you just look at the Landsat, it looks fairly homogeneous. Doesn't seem to be a significant amount of variation. Okay, so let's quickly have a look. It's so slow, it just takes forever. Anyway, so while this is waiting, let me show you. And again, I'm using my print layout format. There is my k-means. N6, this is for 2024, meaning Landsat 9. You can see it's fair, yeah, the clusters are very sure, like fairly homogeneous, nothing spectacular. So, for example, coming back to if we had to do sampling, we know where to do the samples. So we'll do a stratified sampling technique where we have certain amount of equal amount of samples in each of these clusters. So that means it is representative. If we do it totally random and that all goes into the pink areas, then we exclude the red areas, for example. So that's why it's important that we do this so that we can do the proper sampling, because we're going to need those sample points to do our modeling. So it's very, very important that we get understanding. So The k-means method suggests, because remember we had 6 clusters, but basically it just came to about 4 clusters. If you leave the water alone, 1, 2, 3, 4 clusters. And I think even that is pushing it. You can see that area and this area is very similar. We can overlay it with our daytime image. So this is 24. So that area, yeah, it looks like some. You see that area looks like similar to that area. This and okay, anyway, we can go for it. So that's the x-means. Also 6. You can see they're very similar. The clustering, yeah, also just the 5 areas. Looks very homogeneous, huh? Doesn't look very homogeneous. Let's look at Madala. Let's have a look and see Madala, how that looks. That's Madala. Okay, that looks a little bit, still fairly homogeneous, but scattered, much more scattered. It's not that clusters, you know. Looks, especially this area, looks a little bit more. And then the k-means, now here it's only basically 3 clusters. 1, 2, 3, or 4 clusters. Yeah, they're both just 4 clusters. Here it looks a little bit more scattered. Here you can see here it looks a little bit more, yeah, diversified, but still within a small range of clusters. Let's have a look at Bushbuck Ridge. There's Bushbuck Ridge. You can see the different clusters here. Still few clusters, but fairly well distributed. We look at here, you can see there's definitely just basically two broad clusters here. Here's a bit more. Yeah. Okay. So these are cluster profiles of each. Let's have a look and see what happened in. Okay, so there's my Landsat 9 image. There's my Landsat 8 image. There's my Landsat 7 image. Come on. There's my Landsat 5 image. Interesting, Landsat 5. Look at the dam levels. Does it seem like the dam? Look at this part here. Look at that part there. Even there. Landsat 7. You can see there's definitely more water, Landsat 7, than Landsat 5. Definitely. But okay, let's have a look at Landsat 9. Landsat 9 looks like also more water. Much more water. Look there. Look at Landsat 8. Yeah. Landsat 8 and 9. Yeah. So definitely more water. Latter periods than the earlier period. Little more green or more vegetation in latter periods than the early period. Or that's what it looks like. Okay. We'll display the k-means. Let's have a look. It's going to take a while now. And there they all are. And obviously we can export it. And again, it just takes so much time in Earth Engine. So there's the, which you'll see which one is it now. It just takes so much time. That's why I prefer to just export it rather than to wait and wait in Earth Engine. I just basically export it to QGIS and then do the work in QGIS. As I said, otherwise you wait and waste a lot of time. So they are, where are they? Let's have a look. There we go. So there is k-means. There's the k-means. There is the k-mean. That's Landsat 5 k-means. That's Landsat 9 k-means. Landsat 5 x-means. Landsat 9 x-means. If we come 5, let's have a look and see. In 9. You see, it's difficult to compare because the color schemes and everything, the clusters are different between it. So it's not a consistent cluster, so you can necessarily compare it, because I said it's difficult to compare these clusters with one another. So for example, there's one big blue cluster there. That's Landsat 5 k-means. Now if you look at Landsat 9 k-means, that big blue is gone, and it's now pink, red and green. The only thing that's actually here, the river, Landsat 5, the river is green, and here the river is dark blue. So it's very difficult to compare it. It does seem, if you just compare that it's, yeah, it's still fairly homogeneous. There's the x-mean. Look at the x-means in 5. It's blocks. So there's a typical, there's typical, and there's typical. That could be based on the topography, and that's what we're going to test. Could be because of the topography. That's flat land, that's mountains, etc., etc. Who knows? And that's the LQ view in 2009. So it's difficult to get these images, cluster images, to be perfectly aligned because the clusters are different. So you can't simply just take the two images, cluster images next to one another and compare them directly. It's unfortunately not that straightforward because the computer does everything. See, there is, which one is this? This is the Landsat LVQ clustering. That's the Landsat X means, and that's the Landsat K means. Let's see, Landsat 5 K means. And for whatever reason, it struggles quite a bit to display it compared to the Landsat K means. You see, it's almost, there's very little movement on it. Let's give it some time. Let's hope it works. That's what I'm saying. I didn't create a looping function here. And there it comes. Didn't create a looping function. It's just going to bomb out. Trying to create these clustering images for all 4 system is not going to handle it. So let's quickly wait and see. That's a Landsat 5 k-means. You see, limit exceeded. See why I'm not using the looping function. So let's take that one. Let's look at the Landsat 7 k-means. Most probably it's going to give me exactly the same. Most probably going to give me exactly the same. You see, nothing is happening. That's why rather just export it, because it's captured there. It just doesn't display properly. Doesn't mean you can't export it. Because it doesn't display doesn't mean you export it. So just export it. And that's what I've done. I've just exported it, and then in QGIS I have then done it. So there is the clusters. As I said, the purpose of the clusters is to say to what degree does the topography influence these things, and does the degree sort of, so for example, before the mountain is this type of vegetation, after the mountain is that type of vegetation, or is it just one type of vegetation? Is it very various the vegetation? Is it very similar vegetation? Where does it stop? Where does it begin? And as I said, from a sampling point of view, this is obviously going to be very, very important to know these sort of things. Okay, so that's why I have, as an important step, done the clustering. The supervised classification will come, but here I just used the unsupervised classifications. Okay, so we've got the daytime images of each region of median daytime image for each of these reserves. I've got the topography, which is the elevation, which is the hillside, which is the slope, which is the roughness, and which is the aspect ratio. So I've got these ones, and now I've also created the clusters. You can see the clusters to some degree aligned to the elevation. You can see that there's so there is obviously overlap, correlation, etc., etc. Because I mean, this is one system, and all of these variables are attributes are relevant. So that's why I said getting a full and detailed understanding of these reserves are important. Okay, so let me pause there for this particular video tutorial, and we will continue. We still have quite a long way to go. But yeah, see, still, you see, it also gives a red, also means use memory limit exceeded, which is interesting because it's only for the, let's see, 8. Landsat 8, I think, do exactly the same. Interestingly, Landsat 7 doesn't. Landsat 9. But yeah, this is quite a intensive exercise. So ideally, you would have smaller. That's why I think also for your training, for your training cluster, make it as narrow as possible around your region of interest. The bigger you make it, the more it will try to, so I could potentially make it smaller. Yeah, that's a lot. So potentially one can make it smaller, and that should help with the processing. But let's leave it there for now. Okay, so that is an important step. So now I have an understanding of potential sampling locations, sampling methodology, sampling locations. I can now run a regression in terms of the sampling points and these topography characteristics to see what the relationships look like between steepness and the clusters. And although with only 4 or 5 clusters, I don't think that's going to be very meaningful results. It's very homogeneous to a large degree, which is good news from a sampling point of view because it's less samples, which means it's quicker, less expensive, and so forth and so forth. So that's definitely a plus point, having a less diverse area rather than a more diverse area. Okay, so I hope that makes sense. So with that said, let me park there for now. Was there anything else? And obviously, in QGIS, once I have these things, so I have the x means, let's say the x mean or the k means. If I want to map it, I just go back into my print layout manager, click on that, and this was for Loskop Dam. So I just click that. It will open it and it will automatically load it. Now you see here, I'm not going to want the size of this. So I just left click on that, remember. And I go to properties and I go to symbol and I go back to 4. And there we go. So I just amended. That was the only amendment I have to do. I save it again and voila, pops your uncle. That I can copy and paste it into my presentation or Word document or whatever the case might be. So that's how easy. Once I've set up my print manager for each region of interest and its link, I just keep on updating it or refreshing. And that's it. That's how cool these programs is if you link them all together. If you link them all together, it's really wonderful to work with. I think let's park there for now. You see, it's trying to, but it's all 5, 7, and K. So what I'm going to try, we don't have time now. Let's see if I make okay, let's quickly go copy. And then let's delete it. So what I'm going to do now is I'm going to do a new one. And I'm going to see if I can do this as narrow as possible. Can't make it any narrower. Okay, so paste original cluster, take it off, take it out, say run. Maybe that helps if I make that original cluster smaller. I doubt it. Let's leave these ones out. I don't have to display these ones. Let's see if it works now. Let's give it 5 seconds. See if it's better. It should be a little bit easier, but if it takes such a long time, which was probably not going to work either. Let's be optimistic. I started with the Queen song, so let's be optimistic. Nope. Nope, 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 nope. Yep. Yeah, it's not gonna work. Anyway, that's strange because 9 will work. Let's see if 9 works. Yep, 9 works. That's weird. Why is 8 not? Why is only 9? 9 is working without any issues. Is it something in the 5? Why is 9? Is it because of the? Let's do 6, 2, and 6 and 6. Let's do that quickly. Sorry, wanted to stop already, but this is interesting. 5. So let's do the 6. Let's make this 2 and 6. Let's make that 6. For 5. Let's run it. Let's take it off again. Is that the reason why there's a 6? Because that's the only thing I can think of now. Okay, so let's have a look and see if that works now. If it's in the number of clusters where the don't lie. That's interesting. Why would that be the case? See, that's why I prefer to just export the stuff to QGIS, and you don't have these problems. But again, I should no, still the same, still the same, still the same. I don't know why, because the scripts and everything's exactly, it's 5,000. Let's have a look. Scale 9 of 5,000, scale 9, 5,000, scale. Okay, Max. Okay, so let's do that. So why is it different? That's okay. So let's do the same for Landsat. Ah, there we go. It's this. This is the issues. Let's run it again. Ooh. Why? Num pixels, maximum pixels, num pixels. Okay, so let's have a look. Sorry, I'm playing around now because I'm trying to figure this thing out. So 7 is still a problem. Let's have a look if it works now. So what I've done is I've changed that. So let's change. So that's, I've made it 7 now. Ah, come on. So that should still be 30. And then I'm going to take. So why did it say that now? Also still. So what? Oh, that's the export. Yeah, no. No, it's still the same. So let's quickly change this. So if I make that scale Okay, so that's number of pixels. Let's make it bigger. Double it. Let's do this. Scale. Let's make that also. I'm going to see what we're going to do there now. Let's see. So we've got 300 to 5,000. It lands at 9. So if we make that 3FF, let's have a look and see if that works. Because otherwise I'm giving up. I don't know why this is doing this. That's why I'm saying rather throw it into QGIS. Then you don't have to struggle with this. You really don't have to struggle with it. Nope, it's gonna give me. Yeah. I think let's stop here. Otherwise, it's gonna go on and on and on. It's gonna give a. If it struggles like this, it's just gonna say sorry. You're out. So that's not gonna happen. So we've done the 6266. Nope. Okay. Let's forget about it. Let's stop the video here. I think you get the idea. You get the understanding why I'm doing. That's important. Why I'm doing these things or these certain things. What is the thinking behind it? What's the logic behind it? What's the relevance behind it? I think that's the important part. Okay. So yeah, please, yeah, go in and join in and play around in my channel and enjoy it. Go and please like and subscribe, share it. Let these videos run. It does make a huge difference. That's the only thing I ask. So please, yes, enjoy. And I'll see you on the other side.